So welcome everyone to the HEADS monthly seminar. We are so happy that you're here. You took time out of your day. We are really lucky and honored to have Dr. Alden Gross with us today. And he's going to present his talk titled Harmonization of Late Life Cognitive Function Across National Contexts, Results from the Harmonized Cognitive Assessment Protocol, or HCAPS. Dr. Gross is an associate professor in the Department of Epidemiology at the Bloomberg School of Public Health here at Hopkins. He's a psychiatric epidemiologist by training and does extensive research on the relationship between cognitive aging, mental health, and everyday function. Much of his work focuses on statistical methods relevant to things like psychometric measurement and development and measurement harmonization, latent variable modeling techniques, and translation of relevant research findings into public health. He is also has made an art form of the out of office greeting. He's one of the best there. So anyway, I will serve as the moderator, and I think that we will take questions as we go along. So if you have questions, we're going to be monitoring the chat. So just go ahead and put your hand up and or put it in the chat. All right, so I will turn it over to you, Alden.
Thanks, Quincy, so much for that introduction. Of all the things you mentioned, I'm not an economist, so I'm more a psychometrician. I worry a lot about measurement, and whenever I don't know what else to talk about and ask people questions about in their talks, I ask how they measured things. And that usually gives us a lot of fun conversation. As Quincy mentioned, please do interrupt and ask questions as we go along. I've also got the chat open on another window, so I'll be monitoring that. So what are we going to talk about? I'm going to talk about cross-national assessment, and I'm going to introduce the HCAP network. We're going to talk about what is harmonization and some steps to statistical harmonization. There can be other types of harmonization too. And then we'll talk about use of harmonized scores in research. And I've got some slides in the back about how we might use harmonized continuous cognitive scores to derive algorithms for dementia that are comparable cross-nationally. And so I'll give some thoughts about those. Yeah, that's about it. So HCAP stands for Harmonized Cognitive Assessment Protocol, which is an NIH-funded international research collaboration that's been fielded to measure and understand dementia risk. What these HCAPs do is these are individual studies that are usually housed within an international partner study of the Health and Retirement Study and its international partner studies. And there have been HCAPs that are publicly released in the United States and Mexico and England, South Africa, India, and China. But these HCAP initiatives are a real growth industry. This is a priority at NIA. They have funded HCAPs in Chile and Brazil, and there are 2 HCAPs going on in Kenya. There are projects being proposed in Cote d'Ivoire, in Ghana, in Nepal, and Egypt, and Lebanon. And data collection is almost complete in Northern Ireland, and the rest of Europe is coming on boards in early 2024. So there's a lot of interest in doing this. The reason is we don't really have a good sense of the differences in the prevalence of dementia across different countries, and this has really important implications for policies. If there are differences in prevalence, well, are there differences are there differences that are attributable to countries and what countries and or diet patterns are doing? This could be super important. And as it turns out, this is probably one of the best ways for us to begin to understand cross-national differences in dementia prevalence. So before we get to dementia, we have to measure and understand cognition and what cognition is. So here's some study characteristics of, I'm going to focus on 6 of the HCAPS that have been publicly released in England, India, Mexico, China, South Africa, and the US. These are studies of older adults that are, and these studies are as small as 631 people in the South African study, and as large as about 9,700 people in China. The response rates for these studies are pretty good, mostly in the 70s and 80s. What it means to be an older adult varies somewhat depending on the context. So in the U.S. and England, for example, people are 65 and above to be considered old, whereas in India and China, folks are 60 and above. Whereas in Mexico and South Africa, to be old is you're considered old when you're in your 50s and you're eligible for research. The median life expectancy in a lot of lower middle income countries is considerably younger than it is in high income countries. So that has implications for who you recruit into an HCAP study. Not shown on this slide is the age range for one of the HCAPS in Kenya, the KLPS study. Those folks are in their 40s, and we learned that that's a little too young to be considered old. In fact, when we look at how these cognitive tests are intercorrelating with each other in people in their 40s, it turns out that we don't return the expected cognitive domains that we should expect because there's ceiling effects. People are doing too well on these tests in their 30s and 40s. So ho-hum. So the original there's a lot of I'm going to brush over a lot of the origins of how it was decided what tests went into the original HCAP battery of tests. Essentially, it derives from cognitive tests that are used in U.S. Cohorts. Essentially, the University of Michigan team that directs the HRS talked with folks who had done the Ross Map study as well as other experts in the field, and they came up with 17 tests originally. And these things include things like an MMSC, animal naming, trail making, story fluency, or story recall, and word list recall. I see a question in the chat, and I'm going to I'll address that in a second, but let me get through this one slide. The key challenges, for various reasons that we're going to spend quite a bit of time on in this hour, not all the HCAPs administer the same items, and they couldn't due to language issues, cultural factors, and issues related to literacy and numeracy. If you're trying to administer a trail making test to people who are not literate and who are not familiar with who are not as familiar with numbers as the folks on this Zoom, you're going to have a lot of problems. Preeti asks, from where is the sample of HCAP in India taken from? It's my understanding that Lassi was nationally representative, but Lassi Dad is not. So thank you for that question, Preeti. Your question has to do with the HCAP in India, which is the Lassi Dad study. So the Lassi study is the sort of the sampling frame for Lassi Dad. The Lassi study was a study of about 72,000 older Indians aged 45 and above in India. The Lassi Dad study was a sub-study of cognition in India of adults who were age 60 and above. And the Lassi Dad study has 4,096 people from, I believe they sampled from all but 2 or 3 states or union territories. The Lassie-Dodd study is nationally representative, in that they used a sampling strategy, and they've got sampling weights in order to derive nationally representative estimates. Can you also talk about the differences in cognition in Lassie versus Lassie-Dodd? So in the parent cohorts, in like the health and retirement study, there are a few brief cognitive exam questions asking about orientation to time and place, like what state are we in, what's the date, what's the day of the week. And then there's a 10-word recall, a single trial of a 10-word recall. This is true in the HRS, as well as most of its international partner studies, including the Lassie study, as well as the Charles study in China as well. So these are briefer cognitive tests, primarily because these main studies are really concerned with issues around retirement and economics and health, and cognition ends up being just one small piece of these larger studies. So that's why these HCAPS studies came about, so that we could spend 90 minutes asking fun and exciting cognitive tests of people. Does that answer your question, Preeti? Okay, thank you. So as I was saying, in the original HCAP battery as fielded in the US, these tests were developed primarily that have been validated primarily in high income settings in the US and Europe. And not all of the HCAPs could administer the same items. And in order to be able to compare cognition cross-nationally, we need statistical harmonization methods to facilitate this cross-national linking. Many of the HCAP tests were designed to be comparable, and they were doubly translated into other languages. But one thing that's come up is that we can have tests that are properly translated in a linguistic sense, but just because I translate the language of a test does not mean that I've provided an appropriate cultural translation. In addition, there are differences in how tests are scored and interpreted, and how responses are coded. Thus, we can't necessarily be certain that asking a question in one setting is comparable to asking the same question in another setting. For example, let me take myself out of slide presentation for a moment. If you can see my screen, if I were to point to this part of the body, what is this? Anybody can respond. Elbow. That's right. It's an elbow. So why is it that 65% of the sample in Charles gets that question wrong?
Arm.
Right? Or maybe I'm using a local dialect that interviewers decided that I'm not going to accept this local term. We come into these issues all the time. It was thought initially that things like human body parts were, when it comes to naming, object naming types of tasks, it used to be thought, I was taught that human body parts were the gold standard. It was the best way to go. But as it turns out, different cultures and different areas have different ways of naming things. I was just responding to some emails this morning. As it turns out, there's one of the states in India, Assam. I'm going kind of off message here. One of the states in India, Assam, had a different. There was a systematic difference in the elbow question. About 10% of people were getting that wrong. We would expect like 95 to 99% of people to get that right, but there were issues around language. Anywho, I have gotten the same wrong answer to Rhino many, many times on the Mocha, the exact same wrong answer. I always wonder if there's a reason. Thank you, April, for that comment. We'll talk about cacti in a little bit too. Don't you worry. So what's been done thus far in a lot of these HCAPS is that we've demonstrated that similar that these cognitive tests that are administered within a country at least do fit together well in and into broad domains that one would expect. Like if I ask about orientation to time and place, those types of questions broadly fit into an orientation domain. And so what I'm showing here is the factor structure for one of the factor structures that fits really well in the US and English and Indian studies, and actually all of the HCAPS. And so we have other tests of memory, we have tests of executive functioning and of language and fluency and visuospatial ability. So internally within a study, these tests tend to hang together in expected ways. So, as I mentioned earlier, we have this thing called a harmonized cognitive assessment protocol, but we need harmonization because not all of the items in particular were administered and coded and scored in the exact same way. So what do I mean when I talk about harmonization? Well, harmonization is a really broad term, and whenever I hear this word, part of me is part of my when I'm in colloquially, my eyes are rolling to some extent. Harmonization could refer to qualitative assessments of the comparability of some measures. Like, oh, I could say, I've harmonized these things in a broad sense. Harmonization could refer to aspects of a study design. I would say that the harmonized in the term HCAP refers to this, where a bunch of principal investigators decided, hey, we're going to go out and at the outset, we're going to agree on this set of tests. We're going to administer a trail making test using letters and numbers and not circles and squares and not colors. And we're gonna try to use the same tests in our study design in nationally representative samples. Harmonization can also refer to different statistical approaches to link measurement scales or tests. And it's this latter bullet that I'm referring to. Harmonization ultimately can help us synthesize information across different sources, either to have bigger samples or to address novel questions. What I'm really presenting about here is statistical co-calibration. And it's a type of statistical co-calibration that uses latent variables. And this approach relies on the presence of common items that link the studies. There are approaches that don't necessarily rely on latent variables or common approaches, but I think those approaches come with stronger assumptions. Quincy has something in the chat about this looks like a logical memory type test.
Yeah, I don't want it to distract us, but this is just an example of kind of funny items that are on tests that are used all the time in the US at least. And how it's a devastatingly handsome man. And they lived happily ever after.
Yeah, so she married him and they had 3 children. And so this is a really good example that you've got in the chat, because there are story elements here, and the HCAP has a recall actually 2 paragraph recall tests as well. And one of the things, I'm so glad you brought this up. So I glanced at this while I'm speaking, while I'm presenting Quincy. And if I were to recall, some woman had 3 children with a devastatingly handsome person. One of the things when we score paragraph recall, so the HCAP in the US had to go back and completely rescore all of their logical memories because they were using something called exact scoring. So you can't say there was a man who met a woman and the man was devastatingly handsome and they had 3 kids. Um, you would probably only get 1 point out of that recall, because in exact scoring, you have to remember the exact words that were said. There's another type of scoring called gist scoring. And as it turns out, in a lot of cultures, like I'm thinking India and Mexico, where there's a really strong oral tradition for oral storytelling, people embellish all the time. They don't, in that culture, they don't want to recall word for word. There's not this whole zeitgeist around memorization. So they want to embellish. They want to say, oh, so essentially gist scoring makes more sense when you're doing when you want to do cross-national comparisons of cognition. So thank you for bringing this up. Anywho, so who gets to decide what items are common across a study? You know, maybe any generic person can look at an item about elbow naming or about what's a green prickly plant that lives in the desert, and anybody from our own perspective can decide there can't be much variation. Those are similar. It turns out weather test deviations are either exist in the first place, and whether or not they're important can depend on who is looking. As it turns out, most of the PIs of these HCAP studies have ended up being economists for various exciting reasons. But epidemiologists and psychometricians like myself would have different views. Culturally aware neuropsychologists are important to pay attention to. We found that bringing interviewers in the field who have experience with these tests is super critical and super informative. Um, and most broadly, linguists and culturally aware investigators are also very, very helpful to have when you're making these sorts of decisions. So here are a bunch of examples I don't need to go through in detail, but when we're thinking and deciding how we're going to decide whether an item is a common test item across different countries, this is an area of what we call pre-statistical harmonization. And my colleagues, Emily Briseño at right, and on the left, Miguel Arce Renteria. These are cultural neuropsychologists who Emily works at University of Michigan and Miguel at Columbia University. Emily wrote a paper in 2022, and these guys followed up with a 2023 paper where they basically wrote out the steps you need to take when you're documenting information about cognitive test instruments. You have to pay attention to test versions, any adaptations. What were the administration procedures? What were the stopping rules for tests? Were item administrations conditional on other tests? And so on and so forth. We look at language. Some examples include, there's a common test of phonemic fluency where I'm gonna give you a letter, say F, and I'm gonna ask you, say as many words that start with the letter F as you can, and do the same thing with A and S. Well, in some studies, they use F and A and S. Other studies use C and F and L. In Spanish, so if you try to do this study in Spain or in Mexico, there aren't that many words that start with F. So instead of F words in Spanish studies, you want to use PSV. And if you want to do this study in Kenya, you have to pay attention to the words that to the common letters that words start with in Swahili. Um, uh, Administration rules matter. So a related test to phonemic fluency is semantic fluency. Name as many animals as you can in 60 seconds. That's very different from name as many four-legged animals as you can in 60 seconds, or name as many vegetables as you can in 60 seconds. Um, Scoring rules. What types of differences in scoring rules are there if a person has visual impairment or hearing impairment? As it turns out, more than half of our samples of older adults have some sort of either visual or hearing impairment. So as it turns out, it's really important to pay attention to how these things are taken into account. Missing data coding matters. Most studies record missing data due to don't know or refusal, but it's also relevant to know whether a test wasn't even seen by a person because maybe it was not attempted, or maybe there was a physical reason why the test wasn't administered. Maybe there was an issue with literacy or tester error, or so on and so forth. So I said we'd talk about cactuses. So what's a prickly green plant that you find in the desert? I asked Google this question, and the right is the result from Google Images. As a native of Maryland, I had no idea there was this much heterogeneity in what a cactus looks like. I thought the lower right was probably what all cacti looked like, but I didn't know that they have colorful flowers. That's a pretty cool thing. More broadly, do people from non-Western cultures know about a cactus? I was on a preliminary oral exam for an HPM student who is working in Inner Mongolia, and her work has nothing to do with cognition or cactuses. But on her exam, I asked her, "What's a prickly green plant that you find in the desert?" And my point was, this is an issue of, I can do a linguistic translation of this item, but culturally, and she didn't know. She was a very smart 20-something-year-old in a PhD program at Johns Hopkins University, and she doesn't know what's a prickly green plant you find in the desert, because this is not a culturally relevant item to her. Why do we ask this? Because we should be asking questions about a thing that's on the tip of somebody's tongue that they definitely learned earlier in life. So we want to see whether they can retrieve that information from their common memory. So India adapted this item in their wave one. What's a brown nut that contains milk? And there was a problem with that one. In that as it turned out, there were regional differences. Indians in the north are not as familiar with coconuts because coconuts grow along coastlines, and so there was confusion about that. So for the wave two of La Ciudad, they ended up changing that. Preeti asked, do respondents or proxies complete these tests? That's a good question. The respondents complete these tests because we're interested in the cognitive ability of respondents themselves, not of proxies. We do have information from proxies. We ask proxies about informant-related questions about cognitive decline and cognitive impairment. I'm not going to talk about that in the HCAPS. I'm not going to talk about that in this study.
And Alden, while you're there, so Preeti also asked a question earlier about the idea of harmonized protocol being used alone to understand true prevalence, or is it part of a broader assessment to understand true dementia prevalence across contexts?
Right. So what I'm talking about really is the harmonization of cognitive functioning. Now, we've got cognitive functioning. Dementia, I would classify as a wholly different phenotype. Dementia is cognitive impairment that rises up to be severe enough that it interferes with your ability to function in everyday activities. So, what are everyday activities? As it turns out, that varies and depends widely on one's culture. In the US, to be independent, an older adult may be expected to be able to drive to the grocery store, to shop for groceries, to go get their hair done, and then to be able to come home and do some cooking. Whereas in places like China and India, where the elder is the esteemed head of the family, you might not be expected to do any of the cooking. The daughter-in-law does the cooking. Your job is to sit there and be respected. And so, the requirements of what it means to be functionally independent differs across context. So I can talk about that later. And it's an interesting issue, because when we talk about harmonizing dementia algorithms, I'm going to use the word harmonization differently than how I'm using harmonization in the statistical sense here. But we are looking at harmonizing algorithms. What I'm talking about is one component of those harmonized algorithms, which I may get to by the end of the hour, but we'll see. Um, oh yeah, what's a prickly green plant that you find in the desert? As it turns out, this question was asked in the Charles study in China, and only 16% of respondents in China could answer this question. As it turns out, the study in China did not quite pretest their questions as much as they should have. So I love to find examples from them. So this speaks to the importance of cultural translations and identifying culturally relevant terms and words. Back to category naming. So if I were to ask you to name as many animals or fruits or vegetables as you can in 30 seconds or in 60 seconds, it matters whether imaginary animals are allowed. It turns out the Irish study allows unicorns, but nobody else allows imaginary items. The point is, these are supposed to be overlearned categories of things. So in the United States, we're all familiar. Well, if you have children or if you've been exposed to children ever since the 1960s, you are familiar with Eric Carle's Book of Many Things. And I should have had that on my desk here, and I don't. Or maybe you're familiar with Richard Scarry's, Busy Town. These are, we teach children about animals. We teach children about everything that could be green, about plants and vegetables and all these things. So these are overlearned categories that we've been indoctrinating into members of our society ever since they were 2 and 3 years old. In the US, as it turns out, in older adults, fruits and veggies tend to be a gendered category because older women throughout their life course have done most of the shopping. That's why in the US, we tend to try to encourage studies to ask about animals, because we're not going to see gender differences. In this, here's a screenshot of just some mean recalls from the ADNI study. I'm using data information from ADNI 1 and ADNI 2, I think. This is the mean animal fluency for males and females, and there's pretty much no difference. This is the mean vegetable fluency, and females on average can recall an extra 2 vegetables over 60 seconds than males can. In contrast, in the Congo, older adults don't grow up overlearning animal names. You could, as tourists, we could go see lots of animals in on safaris, but normal older adults who work in the Congo don't spend all their time on safari. But everybody buys vegetables in town every day, because you have to buy your fresh fruits and fresh veggies every day. So other cross-country differences in testing that are less apparent, there's a test called the letter cancellation test, where you see it on the right here, where you're supposed to cross off all all the examples of a particular letter as you can on the page. And um, if any of you have spent time in England, you know that the standard page size is A4 size paper. For our US colleagues, that's your legal size paper, I think. I'm not English. But in the US, we use 8.5 by 11 sheets of paper. So in the ELSA study in England, what did they use? Did they increase the font size, or did they add extra stimuli to their version? More broadly, this test requires familiarity with a Phoenician alphabet. So you have to assume that your participants are literate if you're going to administer this test. And again, these types of tasks are things that we overteach our children starting in daycare. This was my, at the time, 3-year-old Benjamin, who came home. He was really proud with this sheet of paper from school, where his task was to spot and dot the letter B, which is his favorite task ever because his name starts with B. So that was great. Wordless learning tasks are a huge swamp to walk through and worry about. It matters whether words are presented verbally or verbally and written down. So as it turns out, in the US, the words were presented verbally and visually. And for literacy reasons, in our lower income countries, the words were not presented visually necessarily. It matters what the lexical frequency of each word in the language is. So if I go back to Quincy's examples about Jack, who was a devastatingly handsome man. Devastatingly is not used in everyday language. We would say it's got some novelty to it. So I'm going to remember the word devastatingly. That's a interesting word. I remember as a participant interviewer myself for the Baltimore Experience Corps trial 15 years ago. I will never forget one participant who I'm pretty sure gave us junk data the entire way through because she had never heard the word frequently before. So when we're asking questions about how frequently you do a certain thing, she wanted to answer frequently to everything because it was the most exciting word ever. Anyway, if you choose words that are very infrequently used in the language, or that are overly common in the language, and if there's a different balance across different languages, you're going to have non-equivalent word lists. You have to pay attention to the syllable count of words, to the serial position in the list, as well as the word's imagery value. We typically like to use hard nouns in a list of words. So back in 2012, I worked on this when I was a graduate student. I published a paper, Parallel but Non-Equivalent Challenges and Solutions for Repeated Administrations of Cognition Over Time. And we found problems in data from the active study as well as from the ADNI study. And I thought we had beat the issue over the head over a decade ago. But lo and behold, different word list versions are still an issue. This is data from our fun and exciting Charles study in China, where we have immediate word recall in wave 1, wave 2, wave 3, and then it tanks in wave 4, and then it jumps up in wave 5. What happened? It turns out in wave 4, they used a different word list, which included words like Mandarin translations of things like beach and butter, which don't have easy translations in Mandarin. And these words, these terms, these concepts are not that common in China. And so the word list was not the same as the word list that was used in the first 3 waves of that study. Fortunately, um, we do have methods to equate these word lists and make them appropriate for longitudinal use. As another example of a word list learning issue, so there is a word list learning test in the HCAPS, a 10-word list recall. The HCAP, Preeti, you'll be interested in this. The HCAP in India was translated actually into 13 different languages, and one of those languages in Karnataka, Kannada. The fun stereotype about that language is that lots of words tend to end in "oo." The joke is, if you're going to the grocery store, just add "oo" to the end of everything, and you're probably not that far away from the correct Kannada version of the word. And then, as it turned out, 6 of the 10 words on the word list when they did their original translation all rhymed. And so, that made it much easier for respondents in Karnataka to perform on that test. Does that mean they have higher cognitive functioning? No, it means they had more help. They had more external aids due to they could use rhyming strategies for their word recall. So anyhow, there are all these differences and concerns to sort out, and we sort those out. We have our experts meet, and we met over a span of about 2 years at the end of the day to work on statistical harmonization issues, and they came up with some decisions about what's comparable and what's not comparable. And I just gave some fun examples of conversations that we've had over the past many years. Let's move in and talk about statistical harmonization approaches for test equating. So our goal is to co-calibrate general cognitive functioning cross-nationally across all of our HCAP studies, not only our existing HCAP studies, but as I mentioned at the start, this is a growth industry. So we're going to be getting additional studies. I'm meeting tomorrow morning about the Chilicog study, because those data are available now, but we're getting new data from, as I mentioned, Kenya, and probably in the new year, Northern Ireland, as well as a bunch of other studies. And many of these studies are planning their second waves. The broad approach that we use is a latent variable approach. So I've got a picture of a confirmatory factor analysis at the top right here, where we have observed cognitive test items. These are questions that are asked of participants, and there are anywhere from 30 to 50 distinct cognitive test items. Sometimes there are multiple test items per cognitive test that are asked in an HCAP battery. The common covariation shared among these tests is represented by this circle here, which is a latent variable for cognitive functioning. And this latent variable could represent general cognitive functioning, or memory, or executive functioning, or any other domain of interest. So we want to be able to co-calibrate general cognitive functioning, and we want to do it in a way where the scores for the studies that we've already harmonized don't change as we add in other studies. So how do we do that? Well, the first thing we do is we do study-specific factor analyses to basically evaluate whether our imposition of an imposed correlation matches the actual data. So we do factor analyses. For example, what I'm showing here at the bottom here are factor analyses of a particular cognitive domain for orientation across all of the studies. And I won't go into great detail, but we look at global fit statistics like the RMSEA and CFI and SRMR. These are really good fits that we can use to support the notion that yes, there is an orientation factor, and it fits pretty well broadly across all of these studies. We next leverage the information from our pre-statistical harmonization phase, and let's go to the text at the top of this slide, and we realize that overall, across a ton of 70-odd different test items, 12 items were judged to be comparable across all of the HCAPS. Another 13 items were comparable across at least 5 of the 6 HCAPS, and 11 were comparable across 4 of the HCAPS, and so on and so forth. So after we've demonstrated that that our domain-specific and general factor analyses fit decently well across each study, and after we've determined which items are comparable or not comparable, we enter into an item banking procedure, and this is really the meat and potatoes slide here. This is at the outset, I'll mention this approach is readily scalable because we can add more studies to this pipeline as we receive them. We ironed out this approach during an RO1 that we had that was led by Rich Jones called the Pitch Project. We worked on this in the early part of the 2010s. That really provided the framework. So what we do is we can break this out into a series of steps. In step one, we take one study. Let's say we start with HRS HCAP. We do our pre-statistical harmonization of items where we recode and redefine items as necessary. We've decided that we can't use exact scoring for our logical memory. We have to use gist scoring. We've decided that, you know, that this elbow naming is an item in HRS HCAP. Okay, cool. Ultimately, we come down to a harmonized set of items, and then we do IRT calibration to estimate item parameters. So for each item, we basically subject it to a factor analysis where we get estimates of factor loadings, the extent to which items are correlated with the underlying factor. And we get item thresholds, which are locations in latent variable space where these items provide information. These are parameters that are estimated in this IRT calibration phase for the set of harmonized test items in study 1. We save all of these item parameters in step 5 into an item bank. This is like a glorified Excel spreadsheet in the sky somewhere. Just think about it that way. We're going to hold on to that Excel spreadsheet in the sky. We're going to now go to another data set. Maybe it's England's ELSA study or Charles HCAP. Anyway, we're going to iteratively go down the line to all of our studies. We're going to do a similar pre-statistical harmonization of items where we're going to make sure that we've used gist scoring for those logical memories. Maybe in China, we're going to treat that elbow item as a different item, as a non-linking item, but the 10-word recall can be a comparable item. And so on and so forth. Ultimately, in this other data set, we have a harmonized set of items. And instead of IRT calibration, in this other data, we do IRT standardization, where we place constraints of parameters on items that are already in the bank. And if there are any new items, new cognitive test items, we freely estimate their parameters and we add them into our bank in the sky. After we've run through this phase for all the studies in our universe, then we can take any future set of harmonized of any future set of data with sets of harmonized items. We can run it through a latent trait estimation software, and we can come up with latent trait estimates. In other words, factor scores that represent a cognitive domain of interest. And these factor scores become variables that we can then use in regressions. I want to note that this harmonization approach is being used in a whole bunch of consortiums. Basically, anything that anybody asks me to use, we use this approach. And so it's fun and exciting, and it works. We've got it working for using different softwares even now. So these are histograms for general cognitive performance and memory and orientation and language and executive functioning for our different studies. The first row is the US, and the last row is the China Charles HCAP. You notice that for the most part, we have fairly normal distributions for cognitive functioning. There are some exceptions, like for executive functioning and Charles HCAP. There's some choppiness because there were only 2 test items measuring executive functioning in Charles. The one really apparent thing you notice is that for orientation, there's a ridiculously high ceiling effect. That's because orientation items are all by and large relatively easy items. We're not asking people about what quadrant in the in the universe or what quadrant in the Milky Way galaxy our solar system is in. We're asking things about what day of the week is it? I think it's a Wednesday. So in addition to estimating people's levels along the latent trait, we can estimate precision or the reliability of individual responses. And so this is a graph of the marginal reliability of that orientation factor score by study in the HCAPS. And on the y-axis is reliability. Reliability tanks basically after a score of 0 on orientation. And when you have really poor reliability, that's when you start to see ceiling effects on the test. This is broadly true of any test that we see. So after we do our statistical harmonization, I see we have about 7 minutes left. We want to make sure that we haven't done anything wrong. One of my favorite quotes is the best laid plans of mice and men often go awry. So did we make a mistake in our pre-statistical harmonization about deciding whether any items were common or not common? Did we miss any cross-study differences, either due to a lack of documentation or because we didn't look closely enough? We have procedures for that we've published on and we've implemented, and they're tailored for this cross-national work, because one of the unique things about this cross-national work that we don't like to make too much of a deal about is that despite the fact that we do believe that we've harmonized cognitive functioning, you do see, if you look just down the column for general cognitive functioning, you do see a systematic shift in the mean structure. In other words, people's locations along the latent trait seem to systematically differ. I think a lot of this is residual effects of literacy and numeracy and just cultural appropriateness of testing in a Western sense. Yeah, all these tests were developed in Western settings. So, but essentially, are there any big items that led to a lot of diff? As it turns out, yes, there were. There's a question in the orientation domain that led to a lot of differential item functioning, or colloquially what we might call bias. And that was, what year is it? As it turns out, in La Ciudad in India, as well as Halsey in South Africa, knowing the year in a Gregorian calendar is not that related to cognitive functioning to one's cognitive functioning level in these contexts. Either year is not used as popularly, or maybe it's in these settings, or maybe it's just not that important. Knowing the day of the week and knowing the season of the year in a rural area, that determines what I'm going to be doing today and over the next week. Knowing whether it's 2023 or 2025, why does that matter so much? But anywho, ultimately, after we do our harmonization and after we do our diagnostics, we like to use our derived scores and inferential models. And there have been several papers that have been published using these scores. And, whenever there's any issues or whenever there's any confusions or oddities that arise, I like to hear about these. because it tells me whether we did something wrong, whether we have to go back to the drawing board. Broadly speaking, we can demonstrate some criterion validation against demographic characteristics. Overall, and in each of these studies, cognitive functioning goes down with increasing age group, and cognitive functioning is higher with more educated samples. This is a really weak form of criterion validation. A stronger criterion validation, I think, would require biomarkers or MRI variables. This is a study that I did almost 10 years ago, where we did a harmonization within the US, and we happened to have cognitive data alongside things like average hippocampal or volume and average cortical thickness. And so we could correlate our harmonized scores with these brain measures, which I think is a stronger form of validation, at least, especially when it comes to cognitive testing. So I talked about cognitive testing and harmonization of cognitive testing, and in the last 3 minutes, let me talk about algorithms for dementia. Study-specific algorithms for these HCAPS have been published for the US and Mexico and La Ciudad in India. Broadly, these approaches are using neuropsychological criteria that are using robust norms. And in India, we've applied a DSM-5 algorithm, which is a little bit different. Our group meets monthly to discuss some issues around implementations of common algorithms in these HCAPS and in others. And one of the things we've learned is conceptually, we're dividing the work into thinking about the components of these algorithms, the ingredients, as well as the recipes. So you can have common ingredients, but how you combine these, just as you can have flour, eggs, and milk are all common ingredients, but the ways in which you combine these ingredients in different ways can give very different, can lead to very different prevalences and very different algorithms, where you can either have pasta or an omelet or pancakes in the case of flour, eggs, and milk. We're in the phase right now where we're documenting similarities and differences. For example, when we look at what cognitive scores are used across studies, India does not use an orientation domain, whereas the US and Mexico do. What are the cognitive score cutoffs that are used for to define cognitive impairment? And is there a justification given for this cutoff? I mentioned, and this came up in a question from Preeti about other aspects of the HCAPS that we have include informant questionnaires, and different HCAPS have different informant questionnaires. We have different restriction criteria used to define a robust normative sample, and I haven't done a good job of describing what that is, but this makes a big difference. And so we're just at the beginning of trying to understand this issue.
So Alden, we
yeah.
have 1 minute left, and do you want to do your summary? And then we have one question.
So yeah, we talked about cross-national cognitive assessment. We talked about harmonization. We talked about steps to statistical harmonization and use of scores and research and algorithms. I want to acknowledge my collaborators. It really does take a large village, and all of our grant funding. Thank you so much. Rajiv asked, is there a pathway from these harmonization efforts to top-line global burden of disease estimates of a dementia? I'm thinking of a partial analogy to other NCD risk factors and diseases where updated, expanded country appropriate surveys help refine estimates. Rajiv, do you mean like a calculation of population attributable risks for these exposures? Yes, absolutely. So we are using these scores. We have a paper that's in peer review to use these scores in India. I have no doubt that people are using these scores in HRS HCAP in the US. I don't know of those efforts in particular, but looking at the analysis of population of attributable risks in high income countries is kind of really, really well done. And so there's a lot of interest in calculating these things in different settings. It turns out that not only are there different associations, but there are different prevalences of different exposures like cardiovascular disease or hearing impairment. That's leading to some very widely different estimates of population attributable risks across different settings. I don't know
All
if that
right.
answers your question.
Thank you so much, Alden, for this great presentation. And I'm sure you wouldn't mind if people have additional questions, they can just reach out to you directly, maybe. Thank you. That was
Sure
fascinating.
thing. Sorry
What
to
great
run
work.
over.
No, you're great. But I know people have to drop off, and people said what a great presentation. So thanks so much.
Cool. All right. Have a fun holiday.
Yeah, you guys too. Take care.